This podcast was produced from a webinar. For a more interactive experience with visuals, visit advancedmanufacturing.org/webinars. Welcome to another SME Media webinar. I'm Carrie Gitter, Associate Editor. Today we'll be exploring the topic Smart Data, Smarter Decisions, Data-Driven Lubricant Condition Monitoring. This presentation is sponsored by Castrol, and we're joined by Cole Turner-Franco, Global Industrial Technical Offer Manager, and Adam Rice, Application Engineer for Industrial Solutions at Castrol. Now it's my pleasure to turn things over to Cole. Welcome. We're happy to have you join us today.
Thank you so much, Carrie. It's a pleasure to be here speaking with everyone this afternoon. We're thrilled to be speaking about data-driven lubrication monitoring today. I'm going to start jumping right into our content. So Carrie did a very nice job of introducing us, but just to cover off very briefly, I'm Cole Turner-Franco, and I'm the Global Industrial Technical Offer Manager at Castrol. And alongside my team, we look after a wide variety of digital solutions and services that overlay on top of many of the products offered from Castrol you're probably already familiar with.
Yeah, and I'm Adam Rice. My title is not a mouthful like Cole's is. I'm an application engineer with Industrial Solutions, right? And so the majority of my days are spent in facilities, helping customers with providing the right lubrication for the right applications, whether that's in gearboxes or in power transmission with hydraulic systems, or machine manufacturing with metalworking fluids. And in parallel, I've been working alongside Cole for the last 3 years now, trying to develop a digital solution to provide continuous monitoring and better insights for our customers.
And it's been a very exciting 3 years, especially as we know that our industrial world is moving very quickly. Our customers are experiencing different stages of digital transformation. Everyone is talking about digitization and AI, but our customers are in widely different places on that journey. And likewise, they're automating a lot of processes, but seeking all of the value and ROI from those automation activities is a bit more complicated than perhaps they thought when setting out on that automation journey. We know our customers are interested in sustainability as it's become either a regulatory requirement, a mandate for efficiency, or in some cases, both. And we are also very aware that there are a wide variety of political tensions, trade wars, tariffs, import-export costs that are a bit more uncertain, that are shifting around the globe and impacting our customers' bottom lines. And again, ensuring that they are really looking at squeezing as much value as possible out of every step in their production processes. And we also know that our customers sit across a wide variety of sectors. And while, of course, Castrol has a wide variety of products to match those sector-specific needs, of course, our auto parts manufacturing customers might have slightly or significantly different requirements than our steel mill customers, for example. But regardless, our customers are all facing a genuine challenge in navigating their digital transformation journey. And I'm going to hand over to Adam to speak a little bit around traditional lubrication and kind of the current state of what we're working with here.
Yeah, and for me, as much as this webinar is about this rapid transformation in industry, right? It's just as much about changing that mindset when it comes to our more traditional reactive type of processes that we have in place now to being more proactive, right? And when it comes to the world of lubrication, there's a lot of area in it for improvement to prevent issues with our lubrication processes. So when I think lubrication, right, like it's the lifeblood of our machinery, right? It's affecting uptime, efficiency, and longevity. And, in parallel, when we think about our lives, I mean, that's very similar to our bodies, right? And so just like I'm not going to wait until the last possible moment to go to the doctor, we're not going to wait until a catastrophic failure occurs to check on our lubricant health. Right, improper lubrication can result in unplanned downtime and costs, increased wear and tear, reduced lifetime of tools, and ultimately it can lead to machine failure. And what's baffling to me, right, is when we step back a bit, we see that like lubrication costs are only about 3% of a maintenance budget, right? And yet they can have a significant impact on all replacement parts, machine and tooling health, even on downtime. In fact, right, Advanced Technology Services conducted a study, right, and what they found was that up to 70% of equipment failures can be attributed to improper lubrication. Right, and so in the context of this changing world, lubrication and maintenance practices must keep pace. So for me, it's much more about like, let's see the world as it is today, right? What do our maintenance practices look like? And just to preface this, right, I have a ton of respect for the maintenance teams out there. I mean, they're asked to do more with less, yet they're a critical component of keeping the facilities up and running efficiently, right? But despite this importance, lubrication management has traditionally been treated as a background task. It's largely reactive, and often this leads to us being blind to problems until damage has already occurred. So if we drill a little deeper, right, into conventional oil analysis, kind of what we see with manualized oil sampling is samples are collected on some regular time cadence, whether that's once a month or once a quarter. Those samples are sent to a lab. Lab analysis has to be performed. And this can lead to up to a 2 to 4 week lag time before the customer gets the lab results. And so this methodology has proved valuable for decades, right? But it kind of has just this one critical fault to it. I mean, when you do it in this manner, what you're only getting is just one snapshot in time, right, of the system health. And oftentimes we're not getting that data until weeks later. So rather than trying to catch something before it happens, we're oftentimes catching it after it happens. So maintenance teams often change the oil based on scheduling because of this, right? So instead of doing actual condition monitoring or condition-based changes, they're doing it from a time-based perspective. Now, this can lead to either premature oil changes, which is a waste of oil, or missed warning signs of contamination and wear. And so this routine approach, while effective traditionally, creates a vulnerability window where problems can escalate undetected. By the time issues such as water contamination, oxidation, or wear debris are identified, the equipment's already operating in a compromised state. Could be for days, weeks, or months even. And this lag creates what engineers call a failure development period, where damage is developed but unseen. So the result is kind of a higher rate of unplanned downtime and a reduction in this failure development period, which leads to premature damage and failure of the machine. So the big question to me is like, why is change needed, right? And so primarily that's to reduce this gap in this failure development period, right? And so what this is, it's the onset of degradation and its detection. And so if you look at this graph that we have on screen here, what you can see is the start of the failure period. Now, the lower x-axis of the graph, we have monthly oil sampling practices. So the first sample that's taken before the start of the failure period, everything looks fine. Take a second sample a month later, slightly after the failure period. But honestly, again, these are single snapshots in time, so a slight increase in some of these parameters is really not going to raise any flags. And of course, if we follow this model forward, what you see is the next sample doesn't occur until the failure's already happened. So this leaves us completely blind to providing any type of intervention to save the component life and to extend the life of the equipment. It's akin to health monitoring, right? Just as we're going into our doctors for a regular checkup to get preventable actions to avoid critical failure of our bodies, right? Continuous oil monitoring ensures that machine health is safeguarded before issues become critical. So reactive maintenance doesn't just cost time, right? It eats into your margins in ways that often go unnoticed. So these hidden costs include unplanned downtime, overconsumption of fluids, component wear and premature replacements, and an increase in resources as additional manpower has to be deployed to work on this equipment, and also an increase in safety risks, right? As these are often in confined spaces or at heights, leading to dangerous situations for our workers. So my big question I want to pose today is, what's the alternative to this process?
And I'm happy to walk through that alternative, Adam, as that's exactly what we intend to offer our customers with Castrol Intelligent Lubrication Solutions. I'm going to walk through the structure of one of our solutions end to end, beginning with point 1 that you see at the top, at the bottom right of the slide, which is your standard lubricant that will feed into your machining process. From there, that's kind of the only similarity point between traditional monitoring and condition live monitoring as we're offering in our intelligent lubrication solutions. A sensor box is installed on the machine that we seek to monitor, right? So where you would typically sample a machine, you install a sensor box there, and there's a different configuration of sensors, again, depending on customer preference and the specific application being monitored. But those sensors then capture live data on the constant performance of our lubricants in real time and feed it to the cloud. And you'll see a bit of architecture and how we've built that solution on the right. We're using an IoT approach, so there are lots of different connected pieces of equipment that are monitoring the machine that is, again, being monitored. We have an edge computing setup where we are aggregating data at the point of data collection to both be secure and efficient with the data that we're handling, but also to set up a responsible cloud architecture. And we serve up that data and the analytics associated to it in a cloud-based platform. So part of why we move data into the cloud is to apply our analytics, to apply some of the algorithms and machine learning applications that a combination of our technology team and our technical engineers, including Adam, have fed into our technology team to structure. Those analytics and dashboards that we share with our customers alert them to whether or not a specific measurement in an application is out of spec, and also if a measurement evolves or changes rapidly or otherwise sends signals that perhaps things within the operation of the machine are not going as they should. And our algorithms are intelligent and learn from themselves over time. And you can see that visualized at the right side of the slide. But last bit, and I think most important to cover, is that by sending out those alerts and by sending out those analytics and sharing them with our customers are then able to take preventative maintenance steps, such that, for example, that water ingress that circulated through an engine for months or several months between measurement periods would be eliminated, because as soon as that water ingress hits that system, is detected by the sensor, our customer or we are able to make an immediate intervention into that machine to do what is necessary to restore it to proper working order. I'm going to walk through a case study where one of our European auto manufacturing customers experienced exactly this. So that customer operates an auto manufacturing site with a sump of about 5,000 liters of neat oil that is circulating through a manufacturing machine. That customer uses our Castrol fluid monitoring services to take regular reports, to deliver regular reports from samples captured from that machine. Whenever that customer received a report from us with either a yellow or a red alert indicating a water issue, which was a persistent issue for the customer at the time, they flushed a significant amount of that sump and replaced it with fresh oil, both as one would expect they would do, but also to ensure that they were addressing the issue once it was diagnosed. And of course, part of why the customer had to flush often a significant amount of that sump was they couldn't be sure of exactly when that water ingress had taken place. It might have taken place the day after they pulled their last sample. It might have taken place immediately before the sample was pulled, or any time between. That customer realized a cost savings of about $17,000 after we installed a couple of sensors on site and were able to serve up data and analytics to them in the manner that I just described in walking through the process. They had access to our dashboard, and they had set up alerts such that their engineers that were able to immediately tend to the machines at issue were able to intervene at the first sign of water ingress. I'm going to hand back over to Adam to speak a bit more about a case study situation that he personally worked on.
Yeah, thanks, Cole. And listen, right, I'm from the show me state. So when I hear something that's all wonderful and great, like, prove it to me, right? And so when they were having success with this technology over in Europe, I had a major U.S. steel manufacturer here in the U.S. That was having problems of their own, right? That we wanted to deploy this technology to. And in their situation, it's similar with the water contamination. It's in a rolling mill, and they had a large central gearbox system that the gear oil system fed 8 different mill stands. And historically, they had consistently seen water contamination events occur which would flood out their system reservoir. They weren't able to identify when the water contamination started, and it wasn't until it was at critical mass that they were able to intervene, right? And over time, they didn't necessarily track the cost impact to them, but they certainly recognized that one was there. And so they came to Castrol and talked to us, and we decided to do a site survey to see if the sensor technology made sense there. We were able to evaluate the system and get a device installed. And once we got it up and operational, just within a matter of a couple of months, you can see on the graph in the upper right that, ta-da, right, a water contamination event occurred. We set limits at 1,000 ppm water content, so everyone would get email alerts to the situation. And once the graph, about August 20th, crossed that threshold, it shot up quickly to over 3,000 ppm. The customer and the engineering team were alerted to this situation, which allowed the customer to intervene quickly, right? They were able to go out into the facility, identify the source of contamination, and shut it off. And then they were able to hook up a vacuum dehydrator to their central gear oil system to start removing that excess water from the gear oil circulating system. And with a matter of just 48 hours, they had dropped the water content below to a reasonable level. And within a week, they had it back to near perfect state, right? Zero ppm. And in collaboration with the customer after this event occurred, we kind of did a cost analysis study to see what was the real impact of this event. And we were able to land on preventing a potential cost of $100,000, right, from this one event. And we've had this sensor installed at their facility for over 2 years now. And since that time, they've had 10 of these events occur. So the initial capital spend on this technology has provided them $1 million in cost savings over the past 2 years. Right. So when I think about it, the benefits case for real-time monitoring stacks up. Right. These are tangible results that maintenance teams can see. There's reduced costs and downtime from early sensor detection that allows early intervention, a reduction in consumables as we move away from a schedule-based approach when it comes to oil replacement to more of a condition-based approach. And then there's also the safety and labor reductions that occur along with this as well.
Thank you, Adam. I'm going to walk through at a high level an overview of the intelligent lubrication solutions offerings. As on the backs of those case studies, we are aiming to provide as much value to our customers as possible through the execution of this roadmap. So I'll start with our advanced lubricants, which is what I suspect most of our customers are most familiar with Castrol for. Those are the products with the OEM approvals, safety and product data sheets, and case studies that you'd come to expect when selecting your industrial lubricant products. From there, our roadmap is heading towards our smart offers, our smart technologies. These smart technologies are intended to overlay on our standard products to enrich the insights and data available to our customers and the performance of those products. We have our fluid analysis services, and we also have these, air quotes, smart offerings. So smart oil, smart coolant, and smart grease are hardware-driven offers. They are named after the fluid or product that they monitor. So smart oil monitors neat oils, smart coolant monitors coolants, metalworking fluids, and emulsions, and the like. And smart grease, of course, monitors greases. Data from those hardware offers will be subsumed into Smart Monitor and displayed alongside fluid analysis data from our standard used oil analysis approach. And together, we aim to visualize all of those insights in one place for our customers. And ultimately, the end goal there is also to enrich the expert services that we provide to our customers today. And that's everything that Adam and his team are providing to our customers again today, to enrich the quality of the advisory, optimization, and analytics that they are serving up to their customers. In parallel, we have our Smart Site offering in development that will support, again, across the board, our chemical managed services offerings, and also enable the manual ingestion and manipulation of data that's captured by a person rather than by a sensor for the Smart Monitor platform. And as you see from the bottom of our roadmap, our future thinking stays around roughly these same themes: quality products, data-driven insights into the performance of those products, tailoring insights and analytics to the technical experts that are supporting our customers along their digital transformation journeys. But I want to speak a bit more about big data and what that means, both for our customers and for Castrol as we seek to evolve the offerings we make. When I think about big data, I think about genuinely all of the different types of touch points with systems, machining, and product that exist at a customer site today. These categories of data that you'll see in this graphic likely either exist in a disparate system, in someone's mind, or in a combination of the two, but likely very seldom do they all exist in a single place. And that, when we start to bring together that data under one roof, under one platform, is when we really start to see a lot of data, a lot of value. Because we're able to overlay that data with machine learning, which, as I kind of referenced earlier, allows our offerings in analytics to grow sharper, more precise, and more valuable to our customers over time. And we're passing that machine learning through the lens of Castrol's technical expertise. We've been doing this for quite some time, over 125 years. And we aim to deliver our expertise and our data in combination to our customers to deliver very quality insights. And all of that exists under the broader umbrella of artificial intelligence, a very hot topic we know for our customers and for us. As you can see from our roadmap at the bottom of the slide, exactly how we intend to deliver value from big data and from AI to our customers. That can be gleaning insights from oil reports captured over time, combining insights from different data sources, and again, sharpening the analytics and insights that are served up to our customers via our technical engineering colleagues. I'm going to hand back over to Adam to speak through the implementation and culture change kind of necessary to deliver on the promise of our intelligent lubrication solutions.
Yeah, and for me, this shift from manual to intelligent lubrication represents a cultural evolution in maintenance, not just a technological one. Right? Maintenance is no longer reactive; it becomes strategic. It's supported by real-time dashboards, predictive alerts, and trend analytics. It's no longer just a cost center, but it becomes a strategic lever for productivity. The automation will alleviate labor shortages by reducing the manual checks, and this will enable skilled staff to focus on higher value work to deliver additional cost savings for the facility. As adoption grows, right, intelligent systems will create a culture where decisions are guided by data and engineering expertise. And this supports more informed decisions and consistent standards across sites and teams. So this transformation supports the wider Industry 4.0 journey that we're all on, embedding digital intelligence into everyday operations for more resilient, efficient, and sustainable manufacturing. And maintenance is no longer just about reacting and responding to failures. It's about anticipating them and preventing them. Intelligent lubrication is enabling this shift. It's empowering teams to make smarter, faster, and more sustainable decisions. So in summary, there you are. I think so. We'll make it happen. So in summary, we know that industrial operations are under pressure to do more with less, right? We've seen the statistics that reveal the troubling outcomes of poor lubrication. We understand that without real-time visibility into key parameters like water contamination, viscosity, oxidation, operators risk running equipment in compromised states, which leads to accelerated wear and decreased asset life. We've seen how traditional maintenance can create hidden costs and lost opportunities. And in contrast, how intelligent lubrication and coolant management can give engineers real-time visibility and control. This will allow them to deliver measurable ROIs and extend asset life. Industrial organizations that delay transitioning to real-time monitoring, they face significant operational, financial, and strategic risks. And they miss the chance to convert maintenance from the cost center into a source of competitive advantage. In turn, companies that embrace this evolution, combining real-time data with expert interpretation, will lead in operational excellence and asset reliability. For any organization operating high-value equipment, the question should no longer be whether they should adopt intelligent lubrication, but when. So let's move forward together. And with that, we want to open the floor for any questions that the audience may have.
Great. Thank you so much, Colin Adam, for such an insightful presentation. We really appreciate it. And it looks like we've received some questions. A quick reminder to our attendees to get your questions in while we still have our experts here on hand. So let's start with this one. How long does a typical installation and onboarding process take?
Yeah, I can go ahead and take that call if you don't mind, just because we've had some recently take place, and so that there's some variability to it, right? But the first step obviously is we like to conduct a site survey to lay eyes on the equipment that we're looking to monitor, and kind of see what types of connections we're going to make, right? And so starting from that point, once that survey occurs, you're typically looking at between 8 to 12 weeks, right? Depending on the manufacturing of the equipment, right? Sometimes, depending on the sensor selection, you're gonna have to pick ones that maybe it's gonna require modification of the device itself, right? So that might extend that lead time a bit. But if we can get the survey in place and it's basically your standard type of setup, we can easily see these deployed in an 8 to 12 week period. Most of that's just hang-ups due to scheduling conflicts between ourselves and the customer.
Great, thank you. Another question here, how does the device connect to the internet?
Oh, I'm happy to take that one if that's okay. So networking is a very interesting topic, especially at industrial sites, because there's a wide variety of ways that we can get data off of the device. So I would say kind of three high-level buckets. Either you can use a cabled internet connection, so you can use a physical cable and connect the device to an Ethernet port. That's possible. My kind of preferred route for moving data is through an LTE modem, just so that you're eliminating any type of prospect of an issue kind of going wrong with your internet connection. And you can also use Wi-Fi in most situations, although captive Wi-Fi or Wi-Fi restrictions on many factory floors can be a bit of a challenge, and also signal connectivity can be a bit of a challenge there. So really a wide variety there in terms of the possibilities for connection to the internet.
Great. Another question here. How is the data collected by the system stored and protected?
Another really good one. So a few ways. So there's encryption end-to-end, both at the device itself while the data is in motion and at the cloud. We're also aggregating a lot of the data in an edge computer at the site of collection. And again, that's all very encrypted and kind of locked down and not easily or readily accessible other than by our technology folks who can kind of do a remote access into the device. So that's at least kind of high level how I would say would be some security. There's quite a bit of lockdown on the physical device itself, and then end-to-end encryption on all of the processes associated.
Great. And who services and maintains the equipment?
Yeah, I'll pick that one up. And so it's kind of a joint relationship in a bit, right? Like the device itself will come with just a maintenance schedule, which is basic like tier 1 activities for the customer to perform. And by that, I mean like you're checking the device weekly for any leaks, right? Just a visual check. We'll also ask the customer, like oftentimes these devices they'll have a filtration set up on the supply side. And so the customer would be asked to like change those filters as necessary. But when it comes to like service and support of the device itself, that actually falls over to our side. So we will provide services to help, ameliorate any issues that arise. We work closely with manufacturing to better understand what needs to be put into place to mitigate any issues. So most of the service and support falls to our side, but the basic stuff we'll ask the customer to work with us on.
Wonderful. Another one here. How does the device handle faults? What are the fail safes?
Yeah, that's a great question. So these devices are, they're in line, but they're not, so they're kind of like a kidney loop, right? So when I think fault, like if something goes wrong with the device and like it's not taking oil or coolant anymore, it has a leak. Like these typically aren't catastrophic because it's typically a small supply line that's right off a low pressure side of the system. So it's not something that we generally see is going to like shut down the facility or anything like that. What we do have on the back end for fault analysis is we get 3 reports a day that highlight the online and offline status of each of the devices that are deployed to the field. So we can see whether the device is connected to the network or not. If it's not, then we would generally we'll reach out to the customer and be like, hey, right, this thing's not connected. Please follow these steps. You can think of me as like your cable provider at that point, because I'm going to be the guy that's like, turn off the modem, turn back on the modem, right? That guy. And so those we have fault setups in place for that. And more importantly, we kind of do sanity checks when it comes to the data. I mean, there's things that happen in oil analysis that just don't make sense. And so we're able to identify that from a report status, right? If we get an alert and we're like, that's weird, none of that makes sense at all. That could potentially be because of a blockage in the system, or, maybe filtration is plugged. We'll reach out to the customer and collaborate with them on that. So I just had one recently, flow rate dropped significantly on the device, and I'm like, weird, right? And I reached out to the customer, and the customer was like, oh, we're in a planned production downtime. All pumps are off. So like, that's why. And it's like, oh, okay. Right. So we work hand in hand with you guys to kind of support that.
Thanks, Adam. Another question. Are there any upfront infrastructure requirements or hidden costs we should be aware of?
Yeah, another great one. I would say, and Cole may be able to add to it too, but from my perspective, I've been on site to install several of these, and like, possibly, right, it's very situationally dependent, right? Like when we deploy these devices for installation, they're going to come with standard connections. Maybe like the oil device, it'll come with a 3-meter hose, right, with the connectors on it. But maybe at your facility, you need to cut that hose down, or maybe you need to extend the hose length, so you build your own hydraulic hose. So those like ancillary costs, right, like $20 in a hose. Same thing when it comes to the modem connection, right? It'll get sent out. Maybe it has a 25-foot LAN cable with it, but you need to run 50 feet to the outside of your building so you can get better cell signal. That's cool. Like, again, it's $20. We're not looking at thousands of dollars in additional hidden costs to deploy these devices.
Terrific. Cole, did you want to add anything to that, or?
No, only brief build is that even when there are, I wouldn't say hidden costs, but additional infrastructure. So for example, if we think about some of our coolant automation solutions, that does involve a degree of either hosing or pipe work to connect the kind of core devices to the sumps or tanks that they're monitoring. There are low cost solutions that can be deployed, like hydraulic hoses that have a life of 12 to 18 months, for example, that you can use in what I'd call a semi-trial, right? So you can we typically will work with our customers and say, right, let's implement this solution. We'll implement it in the lowest cost way possible. There might be more infrastructural investment down the road. If, for example, they really like the solution, want to build it into their processes permanently, they might want to run very high quality pipe work to those devices, right? Definitely a possibility, but not something perhaps that the customer would want to bite off right at the beginning. Would maybe want to say, let's phase this implementation. And that's very much how we've designed these solutions to be deployed.
Great. And here's a question about compatibility. Is the solution compatible with both centralized and decentralized lubrication systems? Yeah,
they absolutely are. I think both of them, both from a coolant perspective and from the smart oiling perspective, they will both work with centralized systems or with decentralized individual sumps. The smart oil device that we talk about, that's a one-for-one setup. So like if you got a central system, like one sump, one device, right? But if you're trying to monitor 8 different gearboxes individually, you're going to need 8 different devices for that, right? Because of the setup that it has. But the smart coolant has the capability of daisy chaining, like up to 11 machines together, right? So you could have one device that monitors one machine. And then if you want to monitor 10 additional machines, you can tie those satellites together to feed off of that one central device.
Great. Another question that just came in from an attendee. What are you monitoring the lubricants for?
That's a good question. Adam, do you mind if I take this one? And if I if I fumble it, please, by all means, feel free to build.
Go for it, man. I'm here for you. Go for it.
So high level, I would say we're monitoring lubricants for changes, especially changes that occur at a rapid pace. So if you think about a neat oil, for example, you want to see a consistent measurement coming through on your water content, right? Being as close to zero as possible. You want to see minimal changes in your viscosity, assuming that the temperature of your application isn't changing dramatically. If you see a rapid spike in a measurement, a sudden but consistent increase or decrease in a critical parameter, that's when you want to act. Likewise with coolants, you want to maintain your conditions to be as even as possible. So if you're dosing concentrate into a sump, you want that concentrate to be as precisely dosed as possible with as little deviation in your target concentration as possible. So that's effectively what we're monitoring for. We're monitoring for any deviation from spec, from standard, or any kind of unusual, what you'd say, movement in the data.
Yeah. No, yeah, that's a great way to describe it. And, I add a bit of context is like, as an engineer, when I work with customers, if you hand me a lab report with one lab sample on it, right, one analysis, there's not much I can tell you, right? Like where content is high compared to normal, but that tells me nothing. I don't know if that's brand new oil in the machine. I don't know if those are new bearings. I don't know if it's old. There's a lot of variability to this, right? And a lot of factors that can affect it. And so with this type of monitoring, it allows us to pull these data points multiple times a day, right? And so like if things are trending upwards, like wear or oxidation, right? These are ones that we're definitely measuring trend. That's a great way to view it because now I have thousands of data points, not just like 3. And then there's these critical situations, right? Like water contamination, like our case studies talked about, like that there should not be a lot of trending to it. There's seasonality, I would say, depending on the region that you're living in. But, if you go from 0 ppm to like 3000 ppm, yeah, like that's a problem, right? So like it provides that type of analysis as well, right? And allows us to intervene. And so that's where this type of technology like covers the whole gamut, right? You're not just getting the trending data, but you're also getting the like critical type of data, right? That something's like, whoa, boy, I need to do something fast.
Great. And so before we close out here, I just want to keep the floor open for any more questions from our attendees. That's some great questions there. And again, the presentation will be available afterward, and you can reach out to the team with additional questions. Here's one. For a grease system, what do you monitor?
That's an interesting one. So a few bits. With a grease monitoring solution, we're monitoring the volume of grease that's deployed to a specific greasing point, if you will. So you're monitoring to ensure that you've appropriately greased that particular site, if that makes sense. And you're also, if you're using the solution in conjunction with an auto greaser, you're just ensuring that there's a flow rate in that device. You're ensuring that there is flow coming through that device and that grease is being deployed where you think it's being deployed.
Yeah.
Thanks, Cole. Did you want to add anything, Adam?
No, yeah, that's a great way. I mean, I think, again, it takes away the blindness from the scenario, right? Like you work, hey, Brian, I know Brian. So yeah, you work out there in the fields and you see these auto lubrication setups and some of them leave you blind. Like you don't know necessarily if it's getting grease or not until like you don't know. And so with this type of smart grease setup, you're actually getting that feed point at the lubrication point itself. So you can kind of see what's happening, right? And whether flow is actually going through it, if you're getting too much pressure buildup that you need to alleviate somewhere. And so it just gives you better visibility again of how are you lubricating your critical assets.
Wonderful. Well, it looks like we haven't had any further questions come in. So we had plenty of good ones there. So once again, I just want to thank Cole and Adam from the Castrol team for joining us today and sharing such an insightful, informative presentation on this very important topic. And I want to thank our attendees for tuning in and your participation, the great questions. We hope you found this content valuable and you'll join us again soon. And until then, remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to podcasts, webinars, including this one, publications, and news by visiting us at advancedmanufacturing.org. Thank you all so much.
Yep. Thanks, everyone.